Okay, am I audible?
Yes.
Yeah.
Okay, I
Who's
think we're
recording?
good
Is
to
it?
go.
Yeah, it's recording. Go.
Okay.
Yeah, okay. I'm Elsa George, B191032EE, and these are my group mates. They'll be introducing themselves.
Hello, I'm Lavkush Pranu, B191184EE. Jadharthan.
Yeah. Okay. I'm Srinathan Jadharthan, B190520EE.
Well, I'm Stephen Francis, B190206EE.
Hello everyone, I'm Anurag Singh and B191040EE.
Okay, so I think we all have like certain questions in our heads, and we'll be asking
Yeah.
randomly. So who wants to go first?
I think we
Okay.
can just randomly go like
Wait.
last time, right? Yeah.
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 Yeah,
Same.
okay, we'll go like last time.
Russian relate. Okay, I shall ask Anurag. What is the concept of Lyapunov stability?
Concept of Lyapunov stability. Okay, I knew this. Okay, yeah. So Lyapunov stability of system is it is determined without solving differential equation. Like when you determine a differential equation without actually solving it, that is Lyapunov stability concept, and it is based on concept of energy. So yeah, these are the two essential points.
Okay, like you can tell like how energy when it's reduced, its stability is interchangeable.
Okay, in next meet.
You ask someone. Wait, we'll try again. Like, Anurag, you ask someone.
Okay, I'll ask. I'll ask Stephen.
Yeah.
Um, Stephen, can you describe the principles which is behind the function analysis?
Okay. Describing function is like a basically appropriate procedure for analyzing a certain nonlinear control problems, and the basic principle is under a sinusoidal excitation, the harmonics present in the output of the nonlinear element is basically ignored, and only the fundamental components of the output is considered.
Okay.
Yeah, I'll ask Lavkush, what are some of the different phase plane analysis method, and can you explain one in detail?
Okay, couple of phase plane analysis method would be analytical, or you can also do graphical or isocline method, and the delta method. I think isocline would be easiest to explain. So isocline, essentially what you do is you would solve a differential equation until you get a like you basically integrate it, and then you get a linear equation which has like a constant value. So you would vary the constant value, which is the slope, from 0 to infinity. So you would get like lines which are acting throughout, and you would mark points on each of the lines accordingly, and then you would plot the phase trajectory along these lines as they connect to essentially spiral towards the center. That's how you can find the phase plane analysis using graphical or isocline method. Okay, I'll ask Elsa. Yours is not done yet, right?
Yeah, no.
Okay. Basics. Explain what phase plane analysis is.
Okay, so phase plane analysis, it's one of the most important techniques when we are like studying nonlinear systems and their behaviors. So it's basically used for obtaining like graphical solutions of two simultaneous equations of an autonomous system, like x1 dot equals f1, a function f1 x1 x2 and x2 dot equals f2 x1 x2, where f1 and f2 are like functions of state variables x1 and x2 respectively. So the whole analysis is basically what phase plane analysis is.
Okay. You ask some.
Okay, I think I'll ask Lavkush.
Again. Okay.
Yeah, like it's related to this. So
Okay, sure.
can you what is the limitation of phase plane analysis?
Okay, that's easier. So basic limitations of phase plane analysis is, as like I said, in my case, I'd taken the example of where you get a linear equation for drawing the diagram. But say, for example, it was of a higher order equation. like the complexity would increase, and hence it will be like harder to like map points along multiple varying what lines of different higher order equations, like say cube or power 20 or 30. Then even if you were to use computers to do it, the computation power would greatly exceed. Hence the only problem with phase split analysis is it lacks expansion where it can use higher order differential equations, and we lack the computation to do it. Okay, so I shall ask Steven.
Yeah.
Um, Steven, so what is meant by phase portrait of a phase plane?
A phase trajectory is a geometrical representation of the trajectories of a dynamical system in a phase plane, and each set of these initial conditions is represented by a different curve or point, and these phase portraits are invaluable tool in studying the dynamical systems. And okay, I'll ask one for Jadatan. What are isoclines and how are they useful in nonlinear system analysis?
Okay, so isocline, it's like it's a curve through points at which parents function slope will always be the same. So like even though there is initial conditions, it will be same. And also it's often used in graphical method of solving differential equations.
Yeah.
Okay, so how many questions did we have? Like I just had one question, I guess.
Even I had one
I
question.
also just
Both
have
of
one
mine are
question.
done.
Okay.
Okay, let's do one more round.
Yeah, so I think I'll ask Elsa then.
Yeah.
Yeah. Okay, so what do you mean by symmetry of phase trajectory in phase plane?
Okay. I'll explain this with an example. So, like, consider a differential equation
Excuse me.
y double dot plus function of y dot equals 0. When we converted it into a phase variable form, it becomes x1 dot equals x2 and x2 dot equals minus f of x1 x2. So when you try to find out slope of phase trajectories and phase portrait, it becomes dx2 by dx1, which is equal to minus f of x1 x2 by x2. So when we're talking about symmetry about the x1 axis, the slope must be equal, but like opposite in sign for x2 more than 0 and x2 less than 0 for all x1. And this is only possible if f of x1 x2 equals f of x1 comma minus x2. So that is basically f of x1 x2 must be an even function of x2. And if we're talking about symmetry about the x2 axis, the slope must be equal, but like opposite in sign for x1 more than 0 and x1 less than 0 for all values of x2. And again, this is only possible if f of x1 x2 equals minus f of minus x1 this time and x2. And this basically implies that f of x1 x2 it should be an odd function of x1. And we're talking about symmetry about both the axes, both the conditions of like symmetry about the x1 axis and x2 axis must be true like simultaneously. And this is only possible if f of minus x1 x2 is equal to minus f of x1 and minus x2. So that's it, I guess.
Yeah.
Uh,
Then
uh,
who else are left? Okay.
Uh,
Anurag is there, no? Someone can
yeah,
ask.
so you ask me something.
okay. Anurag, yeah. Okay, can you like explain the difference between describing function and phase plane method of stability analysis?
Um, Difference between phase plane and describing function methods, right?
Yeah. Describing function and phase plane method of
Huh.
stability analysis.
So, phase plane and describing function analysis method of analysis both use complementary approximations. Okay, where phase plane method retains the non-linearity as such and uses second order approximation of higher order linear part, where the function method retains the linear part and harmonically increases the non-linearity. And describing function method is frequency domain and phase analysis is time domain.
Hmm.
These are four difference.
Okay.
Who's left now?
I
I think
think
we
it's.
all like got 2 questions,
Question one is
right?
left.
Oh,
The
no, no,
pattern
no.
one is left.
I think
just,
I had only one question, no?
Yeah,
Anurag
I
asked
think
Jitata.
someone can ask Jithat. Yeah.
Anurag only, just ask her.
Cool.
Okay, so Jitatan, let me ask you one question.
Okay.
Can you use of phase of linear time invariant system?
Can you repeat once again? Like I couldn't hear properly.
Like I just want to know like 2, 3, 4 uses of phase plan analysis of linear time invariant system.
Okay. So basically, it's the tool to study linear system graphically, and then this analysis gives a very good insight of linear system behavior, and then also we can use this to analyze uh, for extended higher order linear systems. Then what else? Okay, so this local behavior of nonlinear systems can be understood. I mean, using this analysis, and what else? I think I didn't tell this. Analysis is
Eigenvalues.
performed based on eigenvalues and
And
eigenvectors.
eigenvectors.
Yeah. Yeah, I think that's enough. Yeah. So who else are left? Like I think we all had like,
I think
Yeah, I think we're
two or three questions. Like, yeah.
yeah.
Okay then.
Wait, is there anything anyone else wants to like ask or something?
No, I think we can end the meeting here.
Yeah.
Yeah, if we are done, like then we can end up. Yeah.
Yeah.
Well,